Hello, hello. Great. Hello, everybody. Welcome to the Unity Rapid Iteration Workflow for Mobile session. I'm JC Cimetiere. I'm a product manager at Unity. I'm in charge of mobile platforms. And it's my pleasure today to walk you through a lot of tips and tricks, some new features, some maybe not so new features that you may not know that are really useful to get things go a little bit faster. So, as you know, playtesting in the Unity editor is pretty fast, but when you have to test content on device, it takes time. You have to build, deploy, and rebuild, and redeploy. It requires devices, sometimes lots of devices, because the mobile ecosystem being super rich, the diversity of devices is almost infinite. But we want things to go faster. And so today I'm going to walk you through a few different aspects of getting faster. So first, we're going to look at some of the new features available in Unity to make things go faster in play mode. Then we're going to look at how to take advantage of faster builds in some scenarios. We'll look at some content iteration tips and tricks and new things that are coming. And finally, we'll look how you could do better device preview inside the editor. So, play mode is something that is one of the key benefits of Unity, being able to basically test right away what you're building. And we've just added a new feature, which is called the play mode settings. And this feature actually is not specific for mobile development. It's like for everything you do inside Unity. It's really an editor feature. So with the normal play mode, every time you enter play mode, there's a lot of things that are happening. So Unity backs up the scene that's open. It backs up the context, reload the entire C# state, so the full domain being reloaded, destroy the content, the current scene in memory, and then reload that scene to make a fresh setup for your session. And obviously, the more content you have on the scene, the longer it takes. So with this new option, when you enable that kind of settings, you're going to skip a bunch of those steps and basically have a much, much faster rendering of your scene and start into play mode. So to give you an example of how it looks here, I have a little sample application that I've started in using the two different options. So just look, we start at the same time, and the one at the bottom is actually have the play mode option enabled, where we actually disable reloading the domain and reloading the scene. Goes way, way much faster. So in this case, we have a timeline that is starting right away and then transitioning to the gameplay. And so fine-tuning exactly how that transition happens, you really need to do that in play mode. But it's also a lot of small fine-tuning. So every time you go into play mode, in this case, you save 5 seconds. And assuming you do that dozens of times, at the end of the day, it adds up. So play mode is available in 19.3. It's available as an experimental feature. If you look at the blog post that we published a few weeks ago announcing the 19.3 beta, there's a lot more details about that feature, because you have to know that when you disable reloading the domain, reloading the scenes, there are some aspects of your code that will not work. So you have to be aware of what's possible and what's not, and make sure you understand how that feature works to take advantage of it as best as possible. So next, looking at faster builds. We have a new feature we added in 19.1, which is called script-only patching. But first, script-only is a feature that has been in Unity for a little while, available on all platforms. Anyone familiar with the script-only feature? Want to raise your hand? Actually, not that many. I mean, I can't see so much. So really, script-only is a super interesting feature, because what it does is, instead of going through a complete build steps where it's going to build the whole content and then package everything, script-only will go through all of those, except it will skip the whole content build pipeline, and it will recompile and rebuild only your scripts, and then finish the rest of the packaging. So what we've added in 19.1, which is available for Android only for now, is the way to not only skip the content building, but it's going to skip also the rest of the building steps which are building the APK. So essentially what you're doing is just recompiling your code, creating a new assembly, and when Unity does, when you hit that patch and run or just patch feature, it's going to redeploy this new assembly in a cache folder of your application. So the only constraint is that you first need to do a full build and deploy to your device, but for subsequent builds, you only need to use this feature. So let me show you that in action. So first, I have this little sample. I make a first build. So obviously, I sped up the build. In real time, it would have been like a minute and something. So that APK is being pushed to the phone. The application starts. As you can see, the score is at 0. So in this case, my code change will be super basic. I want to cheat a little bit, so I want to give myself some advantage. So I'm going to go to the code, just change the value, start the score now at 10. You know, why not? And then here, I'm going to activate the script-only build. And because I've done a build previously, now I can activate also the patch and run. So in this case, it's going to just recompile the assembly. And let's time that. This time it's in real time. Didn't speed up the thing because it takes only 18 seconds, almost, well, close to 19 in this case. And so the app restarts, and as you can see, when it starts, the score will be already at 10. So when you have an APK that is pretty heavy, that has a lot of content, it saves you a lot of time, and you can iterate on your code really fast. So that's one way that's available, and I really encourage you to take a look at that feature. We shipped it in 19.1, it's there now, and since I didn't see a lot of hands raising when I talk about script only, really use it. This is super useful. So now we were looking at code iteration. Now let's take a look at content iteration. So I hope you had a chance to catch the keynote last night. We introduced Live Link, which is an experimental feature that will come with 19.3. And the idea of Live Link is to be able to make changes right in the editor and have those changes propagate to all the players that are connected at the same time. So it's really a live connection between your authoring content and the content that you've deployed already to devices. So you'll be able to edit meshes, material, texture, pretty much any kind of content. So it's using the power of dots and entities to synchronize a change set. So it sends to the actual players only the change set, which is why it makes it possible to go really fast. So because it's available only for dots scenarios, it means it should really encourage you to start exploring the value of using dots in Unity, because that's, in addition to some of the performance gain that you can get at runtime, during authoring, that's one of the key value that is coming as well. So, but if you're not ready to use dots, and you might be working on a current project, or you might not be ready to learn the new steps to adopt the dots technology, there's also an option that exists currently in Unity using addressable to iterate on content. So addressable is a new way to basically organize your asset bundle, but it's a way that brings one of the key value of addressable is really to bring a super flexible way of managing your asset bundles. You don't have to decide in advance where you want to package or deploy those bundles. Even if you have configuration files to kind of predetermine where, if you want those bundles to be remote, or if you want those to be locally deployed with your application, that kind of configuration can be changed anytime. And in code, the only thing you do is just load assets, and then the dictionary will know where those assets are and load them appropriately. So we can actually use that scenario when you are in development mode And Unity addressables asset offers editor-hosted mode, where in this case, you're going to make a build where none of your asset bundles will be packaged with the player. And so in this case, my first build will be still the same application. So at the bottom, I have a few cards that are being loaded. And I realize, OK, now I'm going to create a new card. And that new card is the mage, which is just a new option. So the only thing I'm going to do is just build the player content in the editor. I don't have to do a rebuild of my player. The only thing I need to do is stop the player, restart the player, and as I restart the player, the new package, the new content is available. And so you can do that if you iterate on the content, change the art style, and so on. You don't have to do a full build. You can just update the content, rebuild the package that's hosted, the bundle that's hosted in the editor, and then have that being loaded by the player. So another option that is really, really super interesting to iterate fast on content. So addressables are now verified. They are shipped as a package. This package is verified for 19.3, which means it's ready for production. Last year, we did a talk at Unite Berlin that actually explained exactly how those steps work. I really encourage you to explore that. This is one of the value of addressables. There are many other things that are interesting with addressable, but that part is pretty cool. So let's go to the fun part. This is new. And what's not new is the fact that the mobile ecosystem is a very fun one, right? Such a diversity of phone, form factors, innovation, folding, small phone, big phones, notches, no notches, powerful, not so powerful, cheap, expensive, so many phones. This is great. Great, but this is also pretty challenging because when you're trying to design content that is supposed to work everywhere, it's a lot of testing and it's a lot of device you need to have. And so would that be great if I could preview phone resolution and notches in the editor? Or if I could fine-tune the layout of my UI based on all those different kind of resolution and notches. And finally, if I could as well test device-dependent code that I want to write, because I know that if I have such kind of phone, I want that phone to load that content. Or maybe I have other rules. If I know this kind of phone, I know I want to adjust the layout of my UI because I want to take advantage of the real estate that's offered. Well, I'm happy to announce today that we are releasing a device simulator in preview. This new simulator is actually an extension of the game view. And what it does, it actually takes the game view and transform it into pretending it's a phone. And to make it easier for you, we've populated a database of phones, and we'll take a look at that a little bit after. The one thing I want to make sure it's really clear is that this level of simulation is not full simulation. We're not trying to simulate the GPU, the CPU. If you have shaders or content, they're still going to be executed and computed and run by your desktop environment, whatever the platform Unity is running on. But there are a few things that we can simulate very accurately, and those things are basically system information and screen size and layout. So let's take a look at this new simulator. All right, let me put my eyes, get some water, and jump into Unity. So the first demo, first thing, well, it's very obvious, but the way you get the device simulator, you go to the package manager, you make sure preview package is checked, and you'll find the device simulator, just install it. Once you have the simulator installed, you can actually find it right here in general, device simulator, or even easier, you go to your game view and you click on this list box, and here you have the simulator. But wait, I'm not going to show it to you yet. So before going into our simulator, I just want to go through the little script I have here to explain what we're going to be looking at. So to demonstrate the simulation, I have a script here that is actually the script we built to test the new cutout API that we introduced in 19.2 that gives you the position of the notch or notches on Android. Yes, there are phones with multiple notches, in case you didn't know. They're pretty rare, but they exist. And so this API is now available in Unity. On Android, there's actually a native API that gives you the size, position of the notches. On iOS, there's no native API, but we've done the mapping. And so when Unity generates an Xcode project, we have the unity.mm file that contains all the notch definitions. And so when you call that cutouts API, you get the actual size and position of the iPhone notches. So it's a fairly straightforward script. It's going to draw a red rectangle around the notch, if there's one, and then it's going to draw a green one around the safe area, and the safe area being the space where you're sure your content is not going to be obstructed by any kind of UI or hardware element that could be in the way. So let's run that script first. So here I'm running the script in the normal game view. So it returns the resolution I'm currently running at my screen. The safe area here is simply whatever the game view is rendering at. Of course, it doesn't detect any cutout. I'm running on Windows 10 and so on. There's no gyroscope feature on this thing. So I just queried a few of the system information. Now, if I switch to the device simulator, ta-da! You're not impressed. Wait, no, okay, I get it. This is not so impressive. It's just an iPhone 8, so what? Well, the resolution is correct. The safe area is correct as well. There's no cutout. Oh, the gyroscope now returns true. Right, this phone has a gyroscope. So let's look at this one. A little bit more interesting. Now you see the green rectangle shows you the safe area, and you can kind of guess the red one, which is gonna which returns the notches. So let's look at another one. I'm switching to, why not, Galaxy S10. So now you can see a little bit more where the notch area is. So it's basically a spot where you don't want to go. And I don't know if you noticed, but I switched from an iPhone to an Android phone, and I didn't switch platform. So that's kind of one of the benefits of this simulator is that we're basing the simulation on the information provided by this list of phones. So let me see. One thing I wanted to show as well here is, well, it's barely readable here, so I'm just going to zoom a little bit so you can actually see better what the shape of this notches looks like. You can look at this, and then if you want to make sure you always fit to screen, you click that button, and whatever phone or size you're going to use, if I resize my screen, it's going to always adjust. So that's kind of the neat convenience we've added here. So let's go back to simple phone, exit play mode, and now I want to show you something else. So this is all good, and for example, if I'm building some UI, so let's go back to my game view first, and actually my scene view. So I have a very simple UI. So my canvas here has actually two sub-canvas. One of which is going to be my full screen, so I want this thing to, so all the text elements, they need to stick really to the borders, to the physical borders of the phone. And then I have this one, which I want to be constrained within the safe area. So this one has the 4 buttons that are at the corner. And well, The way I can manage that easily in code, actually, I have a script here, which is this canvas helper, which actually, this canvas helper has been written by someone called Adrien Dejon, who is the author of Hidden Falls, a really cool, fun game that's available on pretty much all Unity platform supports. And he wrote the bulk of this script when, I think it's when the iPhone 10 came out, and the first notches appeared, and he was like, I really want to take advantage of the full layout. So he wrote a script that is, fairly simple but super useful, and what this script does is basically checks for orientation, resolution, and a safe area, and then it will adjust the canvas to make sure it fits within the safe area. And so that's fairly straightforward, checking what changes when there's any update, and then applying those changes. So let's see how this thing works, because this script is really cool, but before the device simulator, to test the actual effect of the script, you really have to do a build and test on the device. Here, I can simply start my thing. So in the traditional game view, well, I don't see much. Everything is aligned because, as we've seen on the previous demo, the full resolution and the safe area in the game view are basically the same. But when I switch to the simulator and I go to a more interesting phone, like this one, then you can see now the second canvas has been resized. So maybe you don't see it very well. So let's highlight the background area, which taking the full screen. Actually, the top text is now hidden, which is by design what I wanted. And now this is the safe area, which is the other part of my screen, which by design is also what I wanted. And actually, another neat feature of the simulator is that you don't even need to have those like a visual artifact to see what things are. We have this little feature here, highlight safe area. So if you click that feature, it's going to draw a green rectangle around your safe area. So even if you didn't do any coding yet to position your visual elements, you can actually manually sort of resize your different UI element and then position them appropriately. I can actually also play with rotation. So in this case, I've allowed all the rotation for this phone. So if I rotate, so the top will stay at the top. And as you can see, because on iPhone 10 there is the bottom virtual navigation virtual button, basically, that needs a little bit of space. So you don't want to put anything there because you get in trouble if you do. And so that resizes the canvas the right way, can rotate the other way. And then if you want to actually lock the rotation, you can decide to do so and then get a chance to see, oh, okay, that looks fine. Also, you can decide to inherit from your player settings, or you can decide to just override the different values at that level. So, okay. Now, when we are looking at the simulator, this is a list of phones we have at the moment. And actually, I'm running a slightly older version of the package, so I'm sure we have even more phones. But you don't have to wait for us if you want to create your own definition. So in the package folder, you go to the device definition folder, and you will find all the definitions that are available, the one that shipped with the package. So let's, for example, take a look at our iPhone 10. It's a simple JSON file where all the information related to the simulation are defined. So you have friendly name. We also create an image, an overlay image, to give a better sense of how the phone will look like. We don't have the actual picture of the phone, but just a schematic view, which is close enough to give you a really good understanding of the layout and the screen. So the screen's definition includes all the resolution with all the variations of the orientations, and then further down below, you have all the system information that is mapped inside the simulator. And of course, you can create your own, drop it in this folder. It will reappear as you reload the simulator. We plan to update this database with more phones. And also, we plan to include a way so that you can bring your custom definition, but keep them inside your project folder, not have them in the package. So you can basically put them part of the project, being configuration. So if you're using source control and sharing the project among different people, you can all share the same information. And the last thing I wanted to show is actually we've made the device simulator extensible. Because you know, you all love to create a bunch of tools and extend the Unity editor, and that's one of the cool parts of this new feature is that you can actually create your own simulation. So in order to demonstrate that, what I've used here is we have the adaptive performance package, which is a feature we've introduced earlier this year. This is a feature we started with Samsung that basically gives you information on thermal states of the phone. It tells you the phone is warming up to a point where you're going to be throttled. So there's a lot of data you can gather from here, and in particular, you get data, you get events on the throttling status, meaning that you cool, nothing is going to happen. Then you get a warning that tells you, oh, throttling is imminent, and then you get a warning that tells you, oh, throttling is happening. And so with all those pieces of information, you can actually decide to adjust the content of your game. And this is cool, but in order to test the logic of the choices you made to optimize your content, you have, once again, to deploy to a phone, run the game for some time, so the phone gets hot, and finally those events are being fired up. And it can take some time, and it's also a bit random, so you know, you can use an air blower and an air dryer and then make the phone go a little bit warmer, or put it in the fridge to make it go cooler. That works, but using the simulator can be actually a bit more effective. So in this case, we have a very simple sample where we're starting to instantiate a bunch of magic tower. And actually, before I start playing with the warning levels, I just want to show you what we're doing here. So it's pretty simple. So if there's no warning, we are instantiating the maximum number of objects, which is 150. If we go into imminent, dividing by 4. If it goes into throttling, which means, oh, it's bad, you really have to slow down because the CPU clock is probably divided by 2, same for the GPU, so the OS controls that. You can't do anything. The only thing you can do is reduce the load on CPU, GPU for the phone to cool down. So those things are going to be triggered by just managing through my simulation, creating this throttling event. So the counter is starting to decrease, and visually you can see we have less magic towers being instantiated. And now when I go into, oh, it's throttling, oh, I was. Now that doesn't look so good, so maybe I was a little bit too aggressive, so I can go back to my code and change this. I'm just going to divide by 20, go back to Unity, restart my simulation, and then try again, restart my simulation, and then try again to see if visually I'm happy with what happened when it's in throttling mode, and now it's decreasing. Well, maybe that was still a little bit too aggressive, but at least I get a sense of what I'm trying to achieve as those events are happening. And then once I feel comfortable that this is whatever is happening in the simulation is fine, then of course I will ultimately need to do a build for my device. But it saves me a lot of time to fine-tune these details right in the editor without having to make any final build. So extending the simulator is actually fairly simple. You create your own package that will be sort of a simulator provider, and we do have one here, the Adaptive Performance Simulator, that has basically just a few things. The first two files are here, the UI. So we're using UI element to extend the tree. So, for example, this UXML, which is the declaration format for UI elements, a new UI framework in Unity that we use in the editor. And here you have the thermal section that you can see here, where you define all the different values and types of field that you want. So fairly straightforward. And then the next thing is where you're going to be coding the logic for your simulation scenario. So in this case, and the way you do that, you just implement the iDevice simulator extension, and you return the name of your extension, and that's pretty much it. And it's defining your variables, and then the only thing you have to do is really implement this method. That is the one that we call in our device simulator. So we have this method here that is going to be looking for any additional provider for the simulation that has been registered. And if that's the case, it's going to load your UI, load your logic, and you're good to go. The thing to know is actually you might want to also have a define that checks if the simulator is enabled. So you have two versions of your simulation. Well, you have two versions of your code, one version for simulation and one version for when you're running on an actual device. And to ensure this define is taken into consideration, in the asm.def file, you will declare your define here and make it connected to the device simulator. So it's active only when we have the package loaded. So I guess that's about it for the demo. Let's go back to slides. So to recap, so we have a few things in editor simulation that provides you in the game view simulation of resolution, notches, rotation, safe area. And then we have API shims, meaning that when you make calls to those API, screen and system.info, you're getting the values that are returned. You're getting the values that are defined in the device database, basically a collection of JSON files. And extensibility-wise, you really have to do only create your UI, create your extension, extend the iDevice simulation extension, implement the method I showed, and make sure you have the correct define that are built. This is in preview. It is available now. So if you want to go play with it, documentation was not published as just before this talk. So you get the local version of the documentation, which is a .md file. It's readable, so it should be online pretty quick. But we're really looking forward to get feedback on what you'd like to see in terms of simulation, other scenarios you have in mind. We're also very curious to see what kind of extension you'll be building around the simulator. We're planning to publish a blog post on Thursday that will give a little bit of more details and recap what I've presented to you. And then later on, we'll have a longer blog post that explains a little bit more in details how to create the extensions. But at the same time, feedback is very welcome. This is a brand new thing. This is for 19.3 and forward. So actually looking forward to getting your ideas on this. So before I close, I have just a few more things to consider for iteration. So I talked about that, the bounding box API, so the cutouts API. It's really cool. Use it. It's available since 19.2, and that's really useful to maximize the use of the real estate. Now with 19.3, we have a Logcat integration package that is verified for 19.3. And it's really also super useful. Logcat, if you don't know about it, it's a really powerful logging tool for Android when you are building for this platform. It gives you tons of information, actually sometimes way too much. So for example, in this scenario, I've connected my phone to Unity. Unity detects, so Logcat starts automatically and starts sending a lot of logging information. I don't necessarily care about all of that, but as soon as I start my application deployed to the device, I can say, okay, filter only the events that are related to my game. So I just want to see that. And there you go. I see a bunch of red, which means, oh, I've done something wrong. And yes, actually, I've done something wrong because I messed up my asset bundle configuration, which means my assets are not loaded. As you can recognize, maybe the screenshot from previous slides. Now I don't have any cards. I can't play. That's bad. I'm going to lose. But the cool thing is actually this screenshot was done directly from, if you look on the right side of the screen, there's a capture screen. So right from Unity, you can do a screenshot, and you get the image you can save, and you can send that to your developer or tester, say, hey, something's wrong, here's the message, here's the screenshot, done. So really effective way. And then finally, still, again, in Android, but another way to do debugging, Unity is capable of now generating C-trace markers. So if you want to profile Unity from inside out, because Unity Profiler is great, but it gives you the inside view. C-trace will give you the outside view, Unity running in context of all the other things that are running on an Android device, and sometimes conflicts can happen, and you can discover things that are happening that are not necessarily Unity related, but can influence the Unity runtime. All right, so with that, this is a wrap. So today we talked about a few things, the new enter play mode settings that will really make getting play mode starts much faster. New options for faster build, script-only patching to iterate on code really fast. Few options available to you for content iteration, live link coming soon, available for dots, runtime, and entities, and then the addressable system that will enable you for any Unity project to iterate really fast. And finally, the new device simulator. And before I open up for questions, we'll have a few minutes. I just want to do a quick poll. Yeah, so who has ever used the Unity remote and found it useful? See if you, okay. Some of you, okay, good. Okay, who still uses it? Not many, right? Okay, would you like to get a refreshed version of the remote? Okay, so I think Scott, the director of the mobile team, is in the room. I don't know where he is. But we've been discussing about this, the Unity remote. See, it still says Unity Remote 5. We're in Unity 2020 almost. It needs a refresh. So we're on it, and your feedback is super useful. I promise we'll give you something in the months to come, but I'm glad to hear you loved it. You kind of still want it, but we'll give it to you better. With that, thank you for your attention. We have a few minutes for questions. If you want to go back, there are a few mics in the back. I see one here, and probably there's one here, actually. So.
Hi. Just a question on the adaptive performance that you showed towards the end there. How many devices does it work on?
Sorry, I can't hear.
Oh, thank you. Is that better?
Yeah, it's better, yeah.
Okay, the adaptive performance stuff that you showed earlier, how many devices does that work with?
So adaptive performance right now is for Samsung devices only. So it's Samsung S10 and above, so the new Fold should support it. And it's depending on the Samsung Power SDK, I think that's the name, that is being released to the Samsung devices. So the Galaxy latest generation should get it, but I don't have a time frame.
Okay.
Yeah, if you have a question, you have to go to the mic. Sorry, the mic won't go to you.
Regarding the deploying only the scripts to a device, are there any plans on deploying only changed assemblies if you've split your project into several assemblies?
For which context, sorry?
When you do the patch build
Yeah.
thingy, and let's say you have a lot of assemblies that didn't change and only one that changed,
So right now, it's recompiling all the assemblies and redeploying all of them. It's not selectively just choosing the one you change.
Are there any plans on improving on that?
Not yet. We've been looking at it, but that's something we might consider.
Okay, thanks.
About the cutouts, so they are not, it's a Unity feature, right? So Unity comes with all the cutout information.
Yep.
So what about new devices? Will Unity update those frequently?
So on Android, at runtime, we rely on the Android cutout API. So if you run on a new device that implement that, you will get the actual information. And if you want that information in the simulator, you can simply create a new JSON file and update those definitions to simulate. And on iOS, because there's no API that is provided by iOS to determine the position of the notch, you have either to wait for us to update the generation of the Xcode project, which likely would come in an incremental version of Unity, or you can go update yourself the unity.mm file that is generated when Unity generates an Xcode project, and you can add an extra definition for a new phone that would appear. We try to stay really up to date, and for the simulation and the device database for the simulator, we want to have some sort of mechanism in the future where this is a very dynamic database, and then as soon as a device appears on the market or is about to appear or is publicly available, we will update that database and give you a chance to get it refreshed whenever you want.
Okay, thanks.
All right.
I have a question. Although not yet released, will there be plans to support the Soli chip that the Google Pixel 4 is going to be releasing with?
So whenever there are new devices that are going to be released, we will support them when they're available publicly. One of the cool things of the device simulator is that if you are invited into a special private beta, you can actually create your own definition and start doing the simulation work based on the information you have. And if you have an actual device, you can actually grab all that information. We have actually a utility we use internally to capture the JSON file and almost generate it with little work. We'll definitely will share that as soon as we have a system to create the database. And maybe we'll take contribution from the community with whatever devices are being discovered.
Okay, thank you.
All right, maybe one more?
Hi, I have a question about if Unity is planning to support real simulators.
What do you call a real simulator, like emulators? Or
like Android simulator, iOS simulator, just like Flutter or React Native does.
So, yeah, that's, the thing is, Android simulator is an x86 build, and we actually dropped x86 support for Android in Unity because there was really no usage. So at the moment, we're kind of in between looking at it. This is something we're considering to reinvest into supporting those full emulators. But the problem is usually that the performance that you get out of those emulators is so out of line that it's not very useful. And so that's why with the simulator, we've chosen to simulate what can be simulated in a very accurate way. So we give you information you can rely on, and we don't try to simulate things if we don't think that it's going to be accurate. So especially to test performance, to test rendering, ultimately you need a real device. So that's where we are. But we are considering and exploring options to have a better support for emulators in general.
Thank you.
Well, thank you everyone for those who stayed a little longer. I appreciate it. And please send feedback, rate the session. Hope you enjoyed.